All right, so let's finish up this chapter 5 exam review. So number 25 says 4v plus s all raised to the 5th power. So what we need to do is we need to take this and expand it. It says use the binomial theorem to expand. So the first thing we need to do when using the binomial theorem is get our appropriate row from Pascal's triangle. So since this is a 5, our appropriate row is row 5. So 1, 2, 3, 4, and 5. So that's just a 1. Row 1 is just 1, 1. This row 2 is 1, 2, 1. Row 3 is 1, 3, 3, 1. Row 4 is 1, 4, 6, 4, and 1. And row 5 is 1, 5, 10, 10, 5, and 1. So that's the row we need. I'm going to erase the rest of these for space. Alright, so those are erased. Now I'm going to move these up higher. Alright, so let's get this done. So now we know we're going to have 1 times 4v to the 5th. S to the 0 I'm going to leave off for space. Plus 5 4v to the 4th times s to the 1st plus 10 4v cubed s squared plus 10 4v squared s cubed, oops, plus 5 4v to the 1st s to the 4th, and then plus 1 s to the 4th. Alright, so now we have to go through and actually do all the math with the exponents and then multiplying the coefficients together. So here we need to do 4 to the 5th power times 1, or just 4 to the 5th power, which is 1024 v to the 5th, and then plus, and then here we have 4 to the 4th power, which is 256, and then we need to multiply that by 5, which is 1280, and then v to the 4th s, plus 4 cubed, which is 64 times 10, which is 640, v cubed s squared, plus 4 squared is 16 times 10 is 160, v squared s cubed, plus 4 to the 1st is just 4 times 5 is 20, v s to the 4th, and then this last one, oops, I'm sorry, that's supposed to be a 5. And of course this last one is just going to be s to the 5th power. So now we need to look up here to find our answers. Well, if you notice, they put the s first, which is fine. Doesn't matter because mathematically you can write it either way, so it doesn't really matter. So what it looks like we need to do is we need to look at this backwards and start comparing backwards. So our last/first term over here is going to be 124 v to the 5th. Okay, so that's not 124th v to the 5th, neither is that one, neither is that one. So just based on that term alone, it looks like the answer here is going to be A, but let's check them out. Our next term, 1280 v to the 4th s, yep, 1240 s v to the 4th, same thing. 640 s squared v cubed, 640 s squared v cubed, 140 v squared s cubed is right there, and then 20 s to the 4th v is right there, and then s to the 5th right there. So our answer is A. So don't let this one get you. They ordered it here kind of backwards to what you get when you expand it out, because this is A and this is B, but the way they did it is after they did this, they went back and put the variables in numerical order. So all they did was basically start here and write it backwards. All right. So again, for one like this, when it says use the binomial theorem to expand, you will find your exponent and then you will find your matching row in Pascal's triangle. And of course, those are your coefficients that you're going to use initially. So the 1, the 5, the 10, the 10, the 5, and the 1. And then you just simply go through a to the 5th, b to the 0, 4th and 1, 3 and 2, 2 and 3, and so forth. Then you just simply go back through and do the math. So 4 raised to the 5th times 1 is 1024, 4 to the 4th times 5 is 1280, and so on. Then you're just going to match up your answer. All right, let's go to the next one. 29, it says, what is a quartic function with only the two real zeros given? So we only have x equals 3 and x equals 5. So we need to write our quartic. Well, to turn these into factors, we're going to do x minus 3 and x minus 5, because remember, you always do x minus this number to turn them into factors. Now, remember, now we have to multiply by some q of x. We have to multiply by some polynomial that only has imaginary roots. Well, remember, q of x equals x squared plus 1 will only give you imaginary roots. It'll give you plus and minus I. Because if you solve this, you get x squared equals negative 1. So when you take the square root of both sides, you get positive and negative I. So you simply take the x minus 3, the x minus 5. We're going to multiply those together. Then we're going to take whatever resulting polynomial we get there and multiply it by the x squared plus 1. All right? So let's get our polynomial in the works. So x times x is x squared. That's negative 5x, negative 3x, that's negative 8x. And then negative 3 times negative 5 is plus 15. And now that's going to be multiplied by x squared plus 1. So x squared and x squared is x to the 4th. That is negative 8x cubed. This is positive 15x squared. And then of course we multiply by the 1, so we get plus x squared minus 8x plus 15. So y equals, we have no more x to the 4th terms. We have no more x cubed terms. So now we have 15x squared and x squared, so that's a positive 16x squared minus 8x plus 15. So we know it's a plus 15, so we can roll out b and d all together. And our x to the 4th is positive, so we can roll out c. So the answer here is A. So just remember, we had a quartic, which means we had to have 4 roots. And it said these were the only 2 that could be real. So we have to find 2 additional roots that are going to make this, well, let me rephrase it. We're going to have to find 2 additional roots that are imaginary. All right? So the only way to get 2 imaginary roots is to multiply by x squared plus 1. You could have done x squared plus any number really, but why make it more difficult than you need to? Just multiply by x squared plus 1, and you will get letter A. Okay? So that's 29. Now let's do number 30. It says, wind farms are a source of renewable energy found around the world. The power P in kilowatts generated by a wind turbine varies directly as the cube of the wind speed V in meters per second. If a turbine generates 700 kilowatts in a 12 meter per second wind, how much does it generate in a 6 meter per second wind? All right, so for this one, we're going to have to set up our function. Power equals, because it says the power generated by a wind turbine varies directly. Okay, varies directly. We know we're doing direct variation. All right, so we know we need our constant of variation as the cube of the wind speed V. So V cubed, cube of the wind speed, varies directly with the power. So now we have our equation. We just have to plug in what we know to find A, and then from there we can find P for the 6 meter per second wind. So we know it creates 700 kilowatts of power when with a 12 meter per second wind. All right, so 700 equals A 12 cubed. 12 cubed is 1,728. A, because you can't forget the A. Now divide by the 1728. So 700 divided by 1728. equals, so A equals 0.405. So now that we know what A is, we can set up our function. We know that P equals 0.405 V cubed. So now we can find any power output for any wind input because now we have our constant of variation. Okay, so P equals 0.405, and now the question asks, how much power does it generate in a 6 meter per second wind? We're going to throw a 6 in there and finish summing the problem. So 6 cubed is 216. So P equals 0.405 times 216. So when you multiply that together, you are going to get P equals 87.48, which, well, this would round up to 88 because we didn't use this entire decimal. We stopped it at 3 decimal places. If we would have used this entire decimal, it would have caused this to be higher than 0.48, and it would have made it round up to 88. Okay, so 88 kilowatts of power is what's generated in a 6 meter per second wind. All right, so again, you just need to set up your equation first. The power generated by a wind turbine varies directly as the cube of the wind speed. So this right here tells us we're using direct variation. So we know that power equals some constant of variation times the cube of the wind speed v, so times v cubed. So now we have our equation, and then we need to find a, because once we find a, we can simply plug in any wind speed and get the corresponding power that it generates. So we plug in what we know. We know 700 kilowatts of power are generated at a 12 meter per second wind speed. So we plug those in, solve for A, plug A back in, and then we put in the 6 meter per second wind because that's what we're trying to figure out, and therefore we can find the power. All right. So that's it for the second half of this review. Feel free to watch as many times as you need to. Make sure you come to class tomorrow ready to complete the test. See you tomorrow.